What is up, guys? My name is Neuromeld. We are ready to get back into this episode 2. First off, I want to give out a really quick shout out to first the 10 subscribers as of this video. Thank you so much. I was not expecting to get any subscribers for the next, couple months or so. So quick shout out to you guys. Thank you so much. Another shout out for iScopes. Thank you for commenting those good points that you had. I wasn't even considering, the state of the game, how it's going to initialize. How would we pick up if we do save a load state? And I think those are the things that we are most likely going to be focusing on for episode number 2 of the simple 4X game engine we are trying to build for the units. There's a lot of things that I am still considering as to approach how to implement this, but another good point that iScopes had was it can be complex. It can get complex very quickly, and what I don't want to do is bite more than obviously I can chew. So a quick little update to at least the units is I'm just going to create a simple unit, and it's not going to be constrained. Not constrained. Constrained. Okay, I'm going to type this morning. Not constrained by tile type, at least for now, at least for the initial implementation. And then this can be implemented potentially later on. That way, we'll implement this later on if we get to that point and we notice that the units are moving properly around the different tiles. And given that this is the logical game engine, we'll see if we can implement some kind of simple visualization for this, and each unit is going to have a position associated with it. But in terms of data structures and in terms of how these units are going to be represented, that's going to be TBD as we move along in this project. Just a quick recap for those that are jumping on. If you haven't already, you can go ahead and check out episode 1 of this particular series. I'll give a quick high-level overview of where we're at currently. In the last episode, we set up a simple make file and just a simple main CPP. We probably don't need a main.h for the main.cpp. And this is an example of where I'm at when it comes to C++, right? My goal is to keep on working on my C++ and get to a point where I am not just developing high-performant software. I also want to implement good practices and first principles engineering. That being said, we'll go ahead and delete main.h. We don't need a header file for the main.cpp. We'll go ahead and get rid of that. In the main CPP, all we did was write out the high-level steps that we're gonna start off with for this simple 4X game. Then a simple character out for testing both the make file and the current structure that we have for this 4X game engine make file. So we grabbed this from that initial example. I just took this, pasted it into the make file from that example that we saw in episode 1. Kind of went through fairly quickly. So what I want to do is make sure that there's no errors here and go on from there. Without any hesitation, let's jump right into this thing. So the very first thing that I noticed after I had pushed to GitHub, talking about GitHub, let's go ahead and open up my GitHub. I also had pushed it right after the episode. We'll check which branch we're on. So we're in main. I usually create a main or master, but also create a develop branch. Checkout -b develop. We'll go ahead and add all of these files to this branch, and we'll do a quick push. And then we're going to start branching off of develop for each episode. And then at the end of the episode, we'll probably just push to the GitHub. We'll do git push. This should give me what I needed for this command. Copy. Come on, you. Git push will push this branch up, that develop branch. That's taking longer than usual. Convention for this particular series, what we're gonna do is at the start of each episode, we'll branch off of develop. We'll do git checkout -b. For this series, let's see, we should do the episode number, which is episode 2, /, and then what we're gonna be working on, most likely, probably the game state, right? Initial game state. We'll be working on the initial game state. So we'll check out this branch. we'll make sure to push this guy. E02 / GameState. At the end of the episode, we'll push these changes to GameState. And most likely, at the beginning of the episode, we are going to merge into develop. And then once that's merged, all the changes from the previous episode, we'll go ahead and branch off into the current episode's branch so that we can properly get that flow in with working with GitHub backing up these files. Let's do a quick overview. So we're using C++ here as the build command. A couple flags that we make sure that we're treating all warnings as errors. This will probably enforce good practices. I'm not too familiar with all these other flags. As far as I can tell from the example, these are a couple good flags to have activated when you're barely learning so that the compiler is a bit harder on you. These, I believe, are linker flags. I am also unfamiliar with these, so we're gonna stick with these. Maybe an episode later on or even an episode outside of this series, we can jump into Makefile and make sure that I fully understand how and when to use things. Here we're just defining a couple of targets and directories. Oh, I just noticed we don't need one of these lines. So from the example that we had, this was modules 1, modules 2. What we're gonna do is just delete this because this is redundant. And most likely this, I'm not sure, but this will probably affect the build times, I'm assuming, because if it's doing it twice, not sure. Regardless, we'll go ahead and remove that redundancy there. Make all, we should build everything we need. So these are the build commands. These are the ones that you would run in the terminal. And make all is essentially all we need to build our program. This contains essentially the build commands, the ones that you would run in the command line to tell GCC to build whatever application you're building. We're going to be using build all to build the entire application, and this should throw our build program into apps, and that's just the working name for now for this 4x game baseline 0. A couple of other commands. Build will just make the directories clean, should remove anything that we build if we need to. Info is just to give us the info of the setup. These are fairly simple to run. Now let's just give us what's defined in the Makefile, what it resolves to. I think this is good to go in terms of the Makefile. So this is just as far as I can tell, a fairly simple Makefile. But we'll get better. We'll get better at identifying these Makefiles and reading these and building these. My goal is to get way more familiar and comfortable with C++ before we dive into these different build shenanigans. With that being said, let's jump into the main.cpp. Okay, so here, we've defined a couple of high-level things that we need to implement. Generate the initial game state is fairly general. Like iScopes mentioned in one of his comments, we need to consider the initial state, how the new game is going to behave. And then after that, the other thing we have to consider is load and save. How is the game state going to be loaded and saved? I think as a start, let's define exactly what we are going to need to know to implement a fairly simple game state loader and handler. I know that I want to incorporate object-oriented programming. This particular piece is not to teach you guys object-oriented programming, it's implementation. What do I need to know? How much of it do I need to know to implement a simple form of the specific paradigm that you are trying to implement? The majority of the components are going to be object-oriented programming. For some of the data structures is data-oriented design. And with that, what that gives me is one practice with this completely different paradigm. It's a bit more hardware aware when it comes to loading the different data structures within your program. We'll dive into the details once we get to that step and implement that single unit that is most likely going to be data-oriented design. I'll probably do a quick fast forward during the chunks of my learning piece, and then at the end I can definitely give like a high level, either a high level or during the implementation. I'll give you guys a quick rundown as to how to implement whatever concept we're implementing. One thing that we do need to learn is classes in C++. When I say classes in C++, I am talking simple: constructor, destructor, private, public, those pieces of the class. What do I need to know to just implement the simplest version of these different classes? As we move along through the different series, our classes, I'm expecting they should be more complex. We probably would implement a bit more in terms of different design principles, rule of 5, etc. For now, we'll create simple classes. I probably wouldn't be able to handle, at least at this stage, a harder class. We are going to need some data structures. Keep track of some data structures. And by data structures, I mean most likely structs. And then we are going to need, at least for the game state, and this is particularly focusing on the game state, we need a class to handle the logic of a new game, of a load, save state. We're going to need, for this particular class that I'm thinking about, is a particular data structure to keep track of the game state. So the data structure should capture game state, and this includes, we'll just put it in here. It should capture game state, and this should include the entities, right? And by entities, I mean the user and the enemies, basically the different nations, the nations of the board. This data structure should also capture the units, most likely. Actually, no, at least for the initial implementation, we don't need the units. Let's just capture the entities, which is the nations, both the user and the enemies that are currently on the board. This should also capture how the nations or users and enemies are represented. And this goes back to the class. What classes do we need? We need a class to manage the game state, what it's loading, if it's creating a new game. And then we need a class to represent each nation. And if we really wanted to get into it in terms of different paradigms, we can make this object-oriented, okay? Or we can represent these as data-oriented nations. So each nation would essentially be a collection of, for example, standard vectors. For each nation, a name that will be an array of strings. Each nation will be represented by an index to that particular array. For finances, it's economy, right? It has resources, so the capital will be represented by a standard vector of integers or whatever the case is. We'll probably start with these two classes, and most likely we are also going to need to learn how to handle file reads, writes. We need to learn how to handle the file reads and writes, right? This game state is going to be saved to a file. If a user loads one of these files, whether it's JSON as a start or a binary file, this game state class should be able to parse that file and read it in. We'll focus on these two classes at a bare minimum, at least for this episode. We'll get this right, and then most likely the data structures, right? Because the data structures are going to be used within these two classes. So the first thing that I need to do is do a quick review on classes in C++. And as I've already mentioned, my go-to is learn CPP. Right? This is my go-to currently platform to learn C++. I also have to get into the habit of starting to figure out how to use the CPP references website. That one's a little bit harder to kind of parse. This is, oh man, I would say this is not beginner friendly. For example, let's just jump into modules, right? In modules, you start reading through this and it can be a little complex. This one's not too bad. C++ views multiple translation units, and so this is not too bad, but sometimes this can get a bit overwhelming because the technical detail that I've seen some of these concepts explained, it's fairly in depth. And what I don't like is I don't have the experience as of right now to really parse through these and understand, follow along with what's going on. But that is going to come naturally. I'm not afraid of the complexity. You just need to give yourself the time to, one, start building up more experience, become more comfortable with the language and the syntax. And once that foundational piece is there, then the skill to read through that technical documentation will come far easier. That's been my experience so far with all the other programming languages. For now, what I'm going to jump into is a quick overview for myself of classes, and then we'll go ahead and implement that first skeleton of the GameState class. Okay, we're gonna take a quick little break from learning, doing a quick little review of classes in C++. I think we should start with the nations. In terms of structures, we are going to go into source and outside of systems, because systems is going to contain the classes and systems. They're going to get us input the game state and process and move the time step forward. I guess that's my initial thought of this initial goal. So what I'm going to do for nation, we are going to create a new folder and we're going to call this entities. Right? And inside of entities, the different classes, right? So we're going to have nation CPP, and nation CPP is going to have its header file. So inside of nation CPP, we'll define the nation CPP class, and this is going to be an object that will represent each nation on the game board. So the game state itself, right, the file that we're writing to hold the game state is going to have these objects, and we're going to have to read them in and initialize these nation objects. Let's do a quick simple include IO stream, just so that we include a simple IO stream, and we're going to define a class here. Class is going to be called nation. Nations are going to have states. They're going to have their finance state. They're going to have their unit counts. And since we're going to most likely implement the data and standard vector arrays, nation is going to need an index, right? An index into all of those standard vectors. So what index of the standard vector of data units correspond to this particular nation? So there's going to be a mapping that we have to keep track of. Class nation is going to have a couple, what members are going to be private or what members are going to be public. But for the most part, each class is going to have an access identifier, right? Private. This particular class, we're going to start with just putting everything in public, because I just don't know what we're going to need to protect yet, because I have no idea what this is going to look like and how this is going to be interacting with the game state object class, for example. We'll start with making things public. If you were to start defining the members without these access identifiers, it's going to default to private members. We'll start with public for now, and then we'll build up from there if we need to. For the nation itself, we know that there are two capital items that we are going to want for the two resources that we're going to want to keep track of: gold and oil. So the nation is going to have an int that is going to be representing how much capital this particular nation contains, right? And the game state is going to initialize a number of these nation objects. And it's going to give it, depending on the initial new game settings, a certain amount of capital to the particular nation, whatever that logic looks like. I'm not sure, but we know that this is going to have capital. We know that this is going to have some kind of oil, right? We are going to initialize these when that game state class is going to create these objects, generate these objects. And now that I think about it, these should be private to each nation object, right? We don't want things to have direct access to these. So let's do this. We are going to make these private, and then we are going to have a public, and we're going to define here setters and getters for these two. So the setter for capital, avoid set capital. Yeah, let's just set up some setters, make these two members private. Capital. And then in terms of good practices, I think Learn CPP recommended to use the M underscore to represent member properties. That way here we can do member capital equals capital. We'll create a setter for oil. I don't know how oil is going to be represented in terms of, like, is it going to be in pounds, thousands of pounds? We'll find that out. Those details are implementation details. So for now, we'll treat it as an int, as the magnitude of that int. I don't know yet. We'll figure that out as we go. So member oil is going to be equal to oil. So these are our setter functions. And then we're going to need some getter functions, and this is to be able to acquire that private property from our nation class. So we're going to get capital, and this needs to return M capital property. And then we're also going to need a get oil. This is not returning, it's not taking in anything, but this has to return that M oil property. Okay, so we have our setters and our getters for the two resources. I'm just going to clean this up a little bit just to keep these a bit more concise. I'm just going to have them be on one line. Now, at least for the getters and setters, I think all the getters and setters, I'm just going to keep them like this. Nice and cleanly set up. You can set these up however, you can keep them how we initially had them. But I don't know. This looks nice to me. Getters and setters are going to be bunched up like this. So we have a simple class here, and this class contains two properties. What I am envisioning here, this nation is also going to have an index number that is going to be used to access data structures for all the other data-oriented objects or data structs. Whatever that's going to look like, not sure yet. What we can do here is add an index. To be explicit, this is going to be a data index. And I think this will make sense for the vision that I have once we get to the units part. The last item that we're going to need, I don't know if that should be private. You know what? Let's do this. Let's grab these guys. The resources are going to be private because these seem like we need to protect these, right? In the public, we're going to add the data index to the nation, and then we're also going to need a standard string. What is standard string? And I need to include something. Include. There's a string something. String.h. I think it is string.h. It might be. Let's double check that. There's a standard string class from the standard library that I think we can leverage, and it's easier to work with strings with that thing. So let's search up string.h just to make sure that's the one that I'm looking for. It's probably in the C++. Where's the table of contents? If we search here for strings, and I think it's the one that one of the chapters that probably skipped. Literal, numeral, constant, expression, introduction to, this is the one. Standard string is the one I'm looking for. So include a string. So we're gonna go ahead and include string over here. String is gonna contain the one that I am looking for. And then we can use the standard string class to create strings. Initialize. Okay, sweet. This works. We're gonna use standard string to represent the name. Let's put it on top of data index. I don't know if we need the m dash because this doesn't have a setter and a getter. When we initialize a class, hold on, let me see. How do you initialize a class with private and public properties in C++? To initialize a class with private and public properties, constructor. Oh, the constructor destructor thing. That's right, I totally forgot about constructors and destructors. Private, public. Okay, so this nation, let's go back over here. Oops. Okay, so this nation object is going to be initialized. It needs to be initialized by that game state object. So in the public access specifier, we are going to need a constructor, right? And this constructor is used to initialize with initial variables, depending on what properties your class holds, that particular instantiation of that object. So for this particular nation, we know that it has to have an initial capital, right? Okay, so the nation is going to take in an initial capital, and it's to take in initial oil around the map. And it's also going to need a standard string for its name, so nation name, and then it's going to need 2 colons. It's going to need a name. It's going to need an nation index, data structure associations. It's going to need the capital, the oil, and that should be it for now. Let's go ahead and add our emp name. These are member names. Let's do this. Let's add the m dash in front of these two member properties because they're member properties. We're going to call this a nation name is going to be equal to the name. And for my benefit, I usually try to be very specific with my naming conventions. I've gone into situations where my naming convention was so ridiculous that it's very easy to get lost. There's so many variables that we're most likely going to be creating, and just to make sure we are on the same page when it comes to our naming conventions, to be as explicit as you can. That is going to save you some time in the future. So the data index, this should be not nation index. Data index is used to access all the other data, associated with this particular nation. We're going to need m capital is going to be equal to capital for the nation. And capital here just means money, like, yeah, how much gold money they have. The m oil is going to be equal to this oil input. So this is our constructor. The destructor is called whenever this object goes out of scope. Nation is going to have a destructor, which is represented by that squiggly guy on it. And right now, I don't know if we're going to be managing the memory directly first. Let's figure that piece out, how that's going to work. For now, we'll keep it like that. There is something missing here somewhere. Why am I getting rid of squiggly? Int oil. Squiggly, where are you coming from? Wait, a class needs a semicolon outside of its birth? Oh, this is a good little double check on, just to make sure our constructor is fine. So you have the class foo, it's going to have its public foo. Here's the member initialization list. Oh, we can initialize it like this. Should be listed in order that they are defined in the class. Oh, okay. This is good to know. So this is very good to know. The produce the expected results in case where members are required to be initialized, such as for data members that are consts or references assignments will not work. Members to initialize your members over assigning values in the body of the constructor. Okay, so it looks like, let's do that. Let's do that because this makes far more sense to me in terms of good practices. So what we're gonna do is take these, we're gonna copy them, delete them from the block scope of the class, the class constructor. We're gonna paste them right underneath them, push these over for a bit, and then I'll bring them in a bit more. Put these guys here. We'll take this one, push it back here, and then instead of an assignment, we're gonna initialize these just like this. Move this, give it a comma, give it a comma, give it a comma, initialize instead of assign. We're gonna initialize this instead of assign. We'll fix that squiggly red thing above over there in a bit. And then initialize instead of assign. Bring this in a bit. So our class initializer, class constructor, I don't know what kind of logic this is going to have yet, so no, let's keep it in the same line for now. Okay, this is making a bit more sense. Little by little come together. So we have the nation class. Now we're going to jump over to make sure that the nation.h is properly defined. Nation.h, the header file for this one, we're going to make available obviously the class, and if I'm not mistaken, we also need a header file. So here we go. Header guard, that's what we need. We need a header guard, and this allows us to not double import files into each other. And it's this block. This is what it looks like. What I did is I jumped into nation.h. I added the if not defined nation.h, define nation.h, and it's going within the define block. We're going to define all the class and the member functions, and then end the if block. And if so I don't remember what the class is. Let's go back to here. We'll do proper header definition for a class in C++. So classes and header files. There we go. We're going to include iostream, that's for the CPP. Putting class definitions in a header file. If you define a class, solar CPP, header files, you'll learn blah, 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 naming your class, header, and code files. Okay, so here we go. In our test harness, we have this piece. What I'm thinking here in terms of implementation is most likely instantiate the GameState class. We need this GameState class object to either read in. This guy needs to either read in the GameState file or run a new game, initialize a new game, or initialize. It's going to initialize a new game. If we go back to the GameState sys folder, this is going to have a new file within here. We'll call this GameState. Yeah, let's do that. We'll do GameState CPP. All right. And the GameState. Let's be more explicit. Let's rename this guy. It's not just a GameState, because GameState is going to be the data. Okay, so we're gonna call this GameStateManager. GameStateManager is going to be a class. GameStateManager. Can you tell that I'm using caps lock? I have a very bad habit of using caps lock instead of shift. And that gets me to those weird situations. Have to go back and fix the second letter. GameStateManager is going to essentially instantiate those nation objects. IO stream for now. Inside of GameState, we're going to have your public, and we're going to have your private members. GameStateManager Class doesn't need these parentheses at the top. Inside of public. So GameState, we know we're going to need vectors. So let's go ahead and include the what is it called? Vector library, vector.h. No, this has another name to the file. Include this vector. Sorry. Include vector. Is it just vector? Include vector. Vector called nations. Just initialize that to nothing. Standard vector is missing. Namespace. How do you? What is the standard vector thing? Back to CPP. Vectors. I think it's down here somewhere. Operators, bit manipulation, control flow, error detection, context pointers, compounds, classes, standard vector. Here we go. String, IO string. I'm most likely gonna need include string. So yeah, let's go ahead and add string just in case we need it. I don't know if we are or not, and if we don't, we'll go ahead and remove it. But there's a good chance I might need that guy for a bit. So let's go back to here. Where is standard vector? Standard vector. Probably in here. Standard vector. It is. Yeah. Include vector. And then standard vector. Oh, it's because we need to define the type. I didn't realize that was in the other screen before I started creating the GameStateManager class. So I've defined within the GameState system a GameStateManager that's going to have a class, a CPP file that's going to have a class called GameStateManager. And this GameStateManager needs to track new game, the logic for new game, which means it's going to need to read and write. Oops. It's going to need to read and write. Oops. It needs to read and write, be able to read and write. Well, at least for the new game, this needs to write the initial game state to game state file, whatever that's going to be. And then it also needs to be able to initialize the vector of nation. So each object within this vector is going to be a nation class, which is why I included the nation header file. The new game is going to need to initialize this vector of nations. It needs to take in as input the initial settings for the nations. So these are the oil and the capital. I'm thinking if these nations should have a population, like some of these 4X games do. For now, we'll keep it like this. We'll not worry about population for now. So new game needs to do these three things. However, we're going to represent the board. So, and by board, I mean the states, right? The different territories that our nations are going to be managing. Board. And for the new game, it's obviously initialize. And then we have for the load, save. For the loading and saving of the different game states, this needs to be able to read, and obviously write the game state file. this guy needs to, in the load and save functionality, read it in. Yeah, I don't know what that looks like yet, but for sure we need to read and write this GameState file, and then initialize the game from the load file. So basically injected the data into the GameStateManager, which takes us to the last piece of this GameStateManager class, and that is to update the game state, right? So it needs to be able to update the game state as the time steps move forward. So it's going to take in, this will move the game state time steps forward. So this is going to it's going to manage the overall game state data. The game state data is most likely can be represented, at least in this initial go, as some kind of struct that's going to contain all of these data structs. Inside of entities, what we can do is define a GameState.cpp file. This GameState.cpp file, we'll just include IO stream for now, and then we can include most likely vector, because we're going to use those. We might need it actually. Yeah. This should be include vector. This is most likely just going to be a struct, and this struct is going to be called GameState. And inside the GameState, we need to keep track of the nation objects. We're gonna include our nation.h header file. Include our nation header file. This struct is going to contain a vector, that vector of nations, vector of type nation. We'll call this nations for now. It's going to include the units, whatever that is, that's going to be called. And I don't know yet, so we'll comment this out for now. But it's going to be a vector. Oh, actually, this might just be a struct. Because what I'm envisioning is for the data itself, like amount of units and those kinds of things, that most likely will be a struct of the different unit related properties like health, position on the board. We know we need some kind of struct to represent all the unit data on the board. We'll keep this like this because obviously we've only defined the nation.cpp, so we're only tracking a vector of these objects. So we'll go back to the game state struct. This is going to hold the nations, and this game state struct is essentially what's going to be written and read from the game state file. So inside of here, how do we get the data that's stored inside of nations into a file? So the next step that we need to know, at least for the GameStateManager, is how can I read and write to a file? Actually, before I do that, I think we can figure out what's the best way to write a struct, right? Because that's the game state we want to save to a file and read from a file. So how can we save a struct in C++ to a file? I want to use Gemini there. So file in C++. Okay, so this guy has this simple struct, and he wants to read and write directly from item. Since you have tag C++, so namespace standard, so you're going to use standard all across. Point full, that's just defining. This is a constructor for this particular struct here. Okay, so he's initializing the struct. Character out is writing to disk of stream f out and then path to the file. And then f out, file out, I'm assuming that's what that stands for. And then f out close. Upstream, so fstream. So he's using fstream to write to the file. We can also add to each nation object potentially a writer, some kind of writer function to kind of help out with writing the data that it currently holds into the file. But for now, let's jump back over here to the GameStateManager, because this is the guy that's going to, actually, now that I think about GameState, if you go back to the GameState CPP, this is just going to be a struct. So we might not actually need the CPP for the GameState Struct. Let's go ahead and delete this guy. And then we're gonna jump into the header file. And this header file is going to have the GameState Struct, which is going to be used by the GameStateManager. Jump to the GameStateManager. And the GameStateManager is going to need to read and write from that file. What is the best way to handle the read and writes for this particular file? So let's go back into our browser. We're going to search up what data file format is good for saving game state, or just saving data in C++. See what we can find here. Let's skip the first AI suggestion. Okay, so JSON seems to be receiving a lot of votes. Okay. Simple to read and handle, and there are loads of libraries for it. But if you are not interested in nesting data structures, then TOML is even simpler. So we're definitely going to need to nest data files. So JSON might be a good start for our GameStateManager. If we swap over to our VS Code window, we are going to create inside a source another folder called data. And this is where we're going to store the game states and load from. If we were to run a save game operation. What I'm looking at is over here. So the setter and getter functions are being highlighted, but they're not found, but they're not defined. Define a function from a header file in a CPP. So is it a good practice to define CPP, function definition header? I've done this, but do I have a good example here? Well, you know what? It might be in learn CPP. So if we scroll all the way down here, inside the table of contents, there should be something about classes. Classes inside of dynamic allocation, standard vector, more classes. Okay, so nested types, introductions to destructors, class templates with member functions, friend classes and friends, summary and quiz, classes and header files. All of these classes that we have written so far have been simple enough that we have able to implement the member functions directly inside the class definition. Okay, we've done this for the most part. Inside the class can make the class harder to manage and work with. Using an already written class only requires understanding its public interface, public member functions, not how the class works. To separate the declaration portion of the class from the implementation portion by defining member functions outside of the class definition. Here is the same date class as above, with the constructor and print member functions defined outside of the class definition. Still exist inside the class definition, but the actual implementation has been moved outside. So for this particular class date, you have the private and you have the public, but then the functions themselves are defined outside of the class. And then the date is going to, oh, okay, I see what they did there. Just like non-member functions, the only difference is that we must prefix the member functions names with the name of the class type, in this case date, so the compiler knows we're defining a member class. Oh, so that's what we're probably missing. So if we go back to here, we have these four sets of setter classes. If we were to copy these, take them out of the class itself, and then throw them out here. That doesn't explain this piece though, unless we also add the date namespace, not the date namespace, in our case it would be nation namespace in front of it. But let's go ahead and do that. Let's do void nation 2 colons, set capital. Oh, actually, let's do this. Let's throw it back in here because we still need those within that class, right? Even in our example, we have the date. In the training class, you have the private properties, and you still have the initializer, and you still have the get year, get month, get day. I'm getting a little confused. So this is the class itself defined, and they've just moved the constructor outside and then the print function outside. Print. Okay, let's follow that, because even here the print is outside and they're still calling year, which is associated with the class. So okay, let's continue. So what I did, and I apologize, I was on the browser screen. So what I went ahead and changed for the nation class was created the setter and the getter member functions outside of the class definition itself, and then added the namespace nation of the class to these 4 functions out here. That got rid of the squiggly line we're seeing here, because the compiler can now see that these functions were defined. The question is, why wasn't I able to, I had all the logic, these functions inside of here without the nation namespace. The question is, why wasn't the compiler finding it inside of the class nation? So if we were to go to the example that we found in name CPP, we have this example here. Most often classes are defined in header files of the same name as the class, and any member functions defined outside of the class are put in a CPP file of the same name as the class. Here's our date class, again broken into a CPP file and a .h file. So the .h file is very similar to how we defined it, except we're using capital and oil. We did not add the return, so what it's returning into our header file. Oh, now any other header or code file that wants to use the date class can simply include the date.h. Note that the date.cpp also needs to be compiled into any project that uses date headers, so that the linker can connect calls to the member functions to their definitions. Best practice is to put your class definitions in a header file with the same name as the class, Trivial member functions, such as access functions, constructors with empty bodies, can be defined inside the class definition. Prefer to define non-trivial member functions in a source file with the same name as the class. Okay, that is clicking right now. Okay, so that makes more sense. This is what we're going to do. We are going to revert this to how I originally had it and remove those functions from nation. We're going to take this class, which we've defined in the nation.cpp, delete it from here, and we're going to keep it defined in the header file. For class definitions, define it in the header file. All right, your private and public members, getters and setters will most likely also be defined inside of the header file. Inside of the header file. And for anything that is more complex than getters and setters, that's what we define inside of the CPP file, and we include the nation.header. And then any complex, I would say, member functions are going to be defined in the CPP file. I thought this episode is running almost about an hour, so what I'm going to do is let's end this particular video, this episode 2 here, and then we'll continue most likely posting. I'll try to post probably 2-3 days from now, edit the last pieces of content that I put together. I did push all of the code up to the GitHub, but for the most part, and at least for today, I think I'm gonna call it a good stop for this episode. So thank you guys for joining me. Looking forward to recording the next episode for this series. See ya.